Welcome back to Elementary Statistics. We are in part 21, and we are going to be looking really quickly at the gambler's fallacy. We're going to actually be doing a little TSQL demo here. Now, I should have recorded this after the first independent events, but the way that I've ordered this is coming after the video where there's multiple independent events. But this is a good reminder still, and that is when we're looking at independent events, even when we think about the independent event, one event does not influence another event, okay? So we're looking at independent events, so even if we flip a coin and it comes up heads 10 times, it's not due a tails on the 11th time, okay? So you may hear about a thing called the gambler's fallacy if you're new to this. The gambler's fallacy is just simply, it thinks that an event is likely based on what's happened in the past, even when the events are independent of each other. For instance, people will think that, okay, well, since, multiple times it hasn't landed on the way that I want, or it hasn't been the card that I want, actually in the card, that actually is a dependent event, but the dice hasn't landed the way that I want, this time it's going to do what I want, okay? So, well, and it depends on the card, too. If it's an independent hand, then, if it's a new hand, I should say, then, of course, that doesn't apply. But if it is the same hand, then it does. Okay, so let's look at here really quickly. So up at the top, I just create a table, declare a random number and a starting point, and then, of course, on the bottom, I'm dropping the table. And so I want to focus on the loop. All we're doing is just looping, and then we're getting the heads and tails. So because tails is more likely here than heads, it doesn't mean that the next time that I execute this, that it's going to even out. Even though, of course, Microsoft could, always solve my game here. I'm just totally kidding, but and also I should note, and I can't remember if it's TSQL's random or if it's dot or C sharps. One of the random people have argued about that it's not actually random, and that unfortunately is I don't think it applies in this case, but there have been arguments that it slightly favors one over the other. In fact, what we'll just do 10 because that makes faster. So if we do 10, we get 7 and 3, but that doesn't necessarily mean we're going to get 7 and 3 again, and as we see, we don't. And it doesn't mean we're going to get 4 and 6, the inverse. That time we got 5 and 5, right? So if we keep executing this, it's still going to be, each time, these are all independent events, it's going to be an equal probability of it hitting heads and tails. So it's still going to be 50%. So no matter how many times we execute this, it's not like over the long run it's going to necessarily always even out. It could be slightly more heads than tails. It's just as we get a bigger and bigger sample size, we're going to expect it to conform to with that bell curve, where the majority of the cases, the majority of the times that we flip the coin, it's going to be in the center where we would expect the tendency. So let's see if I can go back to that bell curve really fast. So we're going to kind of think about the bell curve differently, and this will make sense in future videos when we start getting into things like chi-square. So if we go to the bell curve, and I'm trying to go to one that doesn't have, here we go. Here it is. So the majority of the times that we flip a coin, it's going to be closer to, the 50-50 mark. And if we're doing, like, let's say 100,000 flips, it's going to be closer to the 50-50 mark, right? So think of that as being the tendency, right? Let's put the red arrow pointing. So that's where we would expect it to be. There could be a few times where, let's say we flip the coin and, it's more heads than tails. I'm not necessarily saying that would be a left-tailed event, but there's more heads than tail. I mean, a lot more. And that's going to be a more unusual event. But overall, we would expect the majority to conform to this center here, where it's going to be more evenly distributed, especially as we have more cases. In fact, it's very unlikely, but not impossible, but it's very unlikely that if we had, let's say, 10,000 cases, that we would get something like, 9,000 tails and 1,000 heads. But again, that's not totally impossible. So when we think about the bell curve in this situation, we're thinking about where are the majority events going to conform to. And for the record, you could actually do an experiment using this same type of code here, as you can sit there and do, let's say, 100 of these loops and then track it and see what the tendency is, and whether you want to do, let's say, just 1,000, or whether you want to do, or even something like 10. We've seen, 5 and 5, but we've seen also 2 and 8. And so just see, what the shape of that bell curve would look like, where we would expect that the tendency is going to be close. So like 5 and 5 or 6 and 4, maybe 7 and 3, but we would expect that it's going to be kind of rare to get the 9 and 1. Not impossible, but it's going to be rare overall. In fact, I don't think we've had a single 9 and 1. I'm just doing it multiple times just to demonstrate this. But I don't think we've had a 9 and 1 yet. Though you can go back and play the video so you guys have an advantage over me. You can play the video and see if we've had one. But the majority of the cases we're getting that I'm seeing at least right now appear to be 6 and 4. We have gotten some 2 and 8s, right? But the vast majority of these have been, it feels like 6 and 4. Oh, we got a 10 and a 0. Wow, now that that's actually really cool. I'm glad I got that on video. So I'm definitely going to keep this one. Yeah, I did not expect that at all. Let's see here. But yeah, that was one. We got a 10 and a 0, but we didn't get a 9 and a 1. I mean, what's going on there? That's awesome though. But you can see, and you could do this kind of just for fun, just to kind of get a feel for the bell curve. Now, this will make a lot more sense, like I said, when we do chi-square, because when we start looking at the probability of like 0.05, you're starting to understand. So that's what these studies are meaning. They're looking at, the likelihood of all this. So this will make sense more in time. You may want to come back to this video to kind of get a feel, but that gives you something to practice, like a little looping mechanism, so you can kind of see and then shape your bell curve. And you can even make predictions and see, kind of what the likelihood of events are and see just how accurate your predictions are.